Hello friends, today we will discuss Cambridge International AS and A-level Mathematics paper 4 Mechanics, and the paper code is 9709/42, right? So let us see the first question. So friends, we can see the first question. It is saying a crane is used to raise a block of mass 600 kg. We can plot it. Sorry. So there is a mass of 600 kg and there is a crane which is used to raise this block, which is having a mass 600 kg vertically upward. Crane is raising it vertically upward at a constant speed. So first information is our speed is constant. As we know, speed is constant, so its acceleration will be what? Can we say about its acceleration? Its acceleration will be 0. Its speed is constant, direction is also fixed upward, so its acceleration will be 0, right? Through a height of 15 meter, and the total distance or displacement, we can say that is the 15 meter. There is a resistance to the motion of the block. So according to question, there is a resistance, so resistance will be downward since the block have to go upside. So resistive force will work along the downward, vertically downward, right? So there is a resistive force. Let us indicate by FR. This is the FC, force applied by crane, right? So there is a resistance to the motion of the block, which the crane does 10,000 of work to overcome. So to overcome this resistive force, work done by the crane is 10,000 of joule, right? So the question is simple. There is a mass of 600 kg, crane is lifting it upward through a distance of 15 meter, speed is constant, acceleration is 0. There is a resistive force that will be working vertically downward, and to overcome this resistive force, crane is doing work of 10,000 joule. So let us take its first question. The first question is, find the total work done by the crane. So the work done by crane, or we can say total work done. Total work done. So of course this will be this part, work done by crane to overcome the resistive force. So this will be 10,000 joule. This is the work done by crane to overcome the resistive force, plus there will be some extra work, that is the W, which is done by crane to lift this block by 15 meter. We can find this work through this expression. W is equal to what? Force into displacement. Work done is equal to force into displacement into cos of theta, right? So how we can find it? So we can find force. What should be the force? Since its speed is constant, acceleration is 0, so we can say the F net will be 0. This is the very important. Friends, please take care of this statement. Since its speed is constant, so acceleration is 0, so net force will be 0, because force is equal to mass into acceleration, right? So if acceleration is 0, be sure mass will be 0, right? So let's see. If acceleration is 0, so force, that is equal to mass into acceleration, so force will also equal to 0. So here F net is equal to 0. What will be F net? F net will be FC, that is this force, that is the force applied by crane, minus FR, that is the resistive force, that is here FR, should be equal to 0. So we can find FC, that will be equal to FR. crane is applied exactly the same force as the resistive force. So, right. And what should be its resistive force? Its resistive force will be its weight. Its resistive force will be its weight, right? And what will be its weight? Its weight will be mg. So we can find work done by crane to lift a mass of 600 kg will be equal to 600 into g, that is the force, into acceleration. We can take its work done. So work done will be force into displacement. Displacement is 15 meter. We can take the value of g as 10, so 600 into 10 into 15, this much of joule. So this will be 15 6 are 90, and this is a 90,000 joule. So it means the work done by crane to lift the object will be 90,000 joule. So what will be our answer? So we get the value of this work done. So the total answer will be 10,000 plus 90,000 joule, that is equal to 100,000 of joule. This is the total work done by the crane. Okay, friends, let us see the next question. The next question, it is saying, given that the average power exerted by the crane is this much of kilowatt. So what is the power? Power is basically energy upon time, we can say, or we can say energy is equivalent to work done. So we can also say it is work done per unit time. This is the power. So question says the average power is 12.5 kilowatt is equal to work done upon time. What will be the work done? Work done by the crane, because it's the power of crane. So work done will be, right, work done will be work done by the crane. So we have to find the total time for which the block is in motion. We have to find total time. We have to find the time. So simple. So to find the time, we have to put the value of work done by the crane, and it's so simple. So we can find time is equal to work done divided by 12.5 kilowatt. So this will be, we have find the work done in part A, that is the 100,000 joule divided by 12.5 kilo, means that is the this much of watt. We can solve it. This decimal will this. So this will be 1000 upon 125 joule upon watt, that is equal to seconds, and this will give you 8 seconds. So we get the answer of 8 seconds. It means the crane is doing the work of 100,000 joule for 8 seconds. Can we solve this in another way? Yes, we can solve, or we can think this in another way as, please see, we have to find time. We have given power. Power is 12.5 kilowatt, right? We have to find time, right? Sorry. We know power is what? Power is force into velocity. We know this formula. If there is any problem regarding this formula, please comment in comment section. Power is equal to force into velocity. So we have to find time. So what will be the force? force exerted by the crane. For this, let's see, we know the work done. Work done is equal to force into displacement into cos theta. Here cos theta will be what? Work done by the crane. So we have to find work done by crane. Force is upward, displacement is upward, force applied by crane is upward, displacement is upward, so theta is 0, or we can say cos theta is equal to 1. So work done is equal to force into displacement. So we can write force is equal to work done upon displacement. So here we can write power is equal to force, that is the work done upon displacement, into velocity. And what will be velocity or speed? What will be speed? It's distance or displacement upon time. So we can put it, power is equal to work done upon distance into velocity is distance upon time, right? So again, that is the similar thing is coming. Let's see. So we can put it, this will be 12.5 kilowatt is equal to work done. We know the total work done, that is the this much of joule upon displacement. We know the displacement, that is the 15 meter into displacement, that is the 15 meter upon time. See, again the same expression is coming. So you can think in either way, what the expression is same. So we can find from here the t is will be equal to 8 of seconds. Right, friends, this was our the first question. I hope you understood this question very well. I am trying to explain each and every question along with proper theory, so you can revise your theory with these questions also. Let us see the next question. So a particle P is projected vertically upward from the horizontal ground. So there is a horizontal ground. You can say this is the horizontal ground. There is a particle P. So this is the particle P. It's projected vertically upward. So this is projected vertically upward from the horizontal ground with a speed of u meter per second. So its initial speed is u meter per second. P reaches a maximum height of 20 meter of the ground. So its maximum height, let us say this is the maximum height. This is, let us say, maximum height. So at maximum height is 20 meter of the ground. So its distance traveled is 20 meter. We know at maximum height, its final speed will be 0. So we can say its v will be 0 meter per second. This is the important point. So this is the question. So the first question is, find the value of u. So we know the value of v, we know the displacement, we know the acceleration. Acceleration will be minus of g. We will take here acceleration as minus of g, because motion is in upward direction, motion is vertically upward, but g is always acting vertically downward. So if your g is in the opposite direction of motion, you will take a as minus g. If g is in your direction of motion, you will take acceleration as plus g, right? So we have to find u. We can find it. We have the formula v is equal to u plus at. we know the value of v, we have to find u, we know the value of a, but we don't know the value of t, so this is not applicable. Next is, we can say v square minus u square is equal to 2as. We know the value of v, we have to find the value of u, we know the value of acceleration, we know the value of displacement, so this can be applicable. Let us put it. So v square, that is, it means 0 square minus u square is equal to 2. Acceleration is g, let us take it 10, and we have to take it minus of 10 because I have already explained this. Into displacement, displacement is how much? 20, so put it 20. So so it will be minus of u square is equal to minus of 2, sorry, minus of 400. Minus and minus will get cancelled out, so u square is equal to 400. So after taking square root, this will be plus minus of root under 400, and this will be, you can say, u will be plus minus 20, but we have to take only plus sign. We will ignore minus 20 because we have to throw it vertically upward, so we will take only plus 20. Minus 20 is not acceptable here, so the answer will be, the answer of first part will be u is equal to 20 meter per second. Detailed explanation is right in your right side, right? Let us see the next question, that is the part B. It is saying find the total time for which the P is at least, please take care of this point, P is at least 15 meter above the ground. P is at least 15 meter above the ground. So let us suppose this, sorry, this was the particle P. It was projected with the initial speed of 20 meter per second. It go vertically upward till the height of, you can say, 20 meter. According to question, the maximum height is 20 meters. The question is saying find the total time for which the P is at least 15 meter above the ground. Please take care. Height, please take care, very, very important point. Height is measured or calculated. Height is measured or calculated from bottom, right? Or depth is calculated or measured from the top. Very, very important. Small point, but important point. So we have to find the time for which the ball is above the ground at least 15 meter above the ground. It means we have this 15 meter above the ground. Let us suppose this distance is, let us suppose, 15 meter. Let us read the question once more time. Find the total time for which P is at least 15 meter above the ground. Yes. So 15 meter above the ground, it means from the bottom, it is the 15 meter above the ground, right? This position, let us suppose this is the particle P. So this is 15 meter above the ground. So this is the 15 meter, but we have to find the time for which it is above the 15 meter. Please read question one more time. Find the total time for which the P is at least 15 meter above the ground. So we have to find for what time duration the particle was in this region, right? We have to find for what time duration the particle was for in this time duration. We can calculate it very easily. See, we can calculate it in two ways. Let us see the first way. The first method, see, we can calculate it another way. Let us suppose we have to find this distance will be how much? This distance will be 5 meter. How? Total distance is 20 meter. This is the 15 meter. So this will be 20 minus 15, that is equal to 5 meter. So we can calculate it for what time this will be in this region. See, when it reach at the maximum point, it will again start to fall just like a free fall. After reaching the maximum height, it will start free falling. So for the free falling, its initial speed will be taken as 0 for free falling. Its initial speed u will be equal to 0. Acceleration, now we will take it plus of g because the motion is downward. I'm explaining again it. Motion is downward and acceleration always acting downward. So both are in the same direction. We will take acceleration as plus of g. We know the value of displacement as that is equal to 5 meter. We have to down only 5 meter, right? So we can calculate its time. How much time? So we can calculate it. S is equal to ut plus half at square. S is equal to 5, u is 0 plus half acceleration, we can take it 10 and t square. 2 say 5, 5, 5 cancel 1. So 1 is equal to t square, or we can say t is equal to 1. It means to fall it from the maximum height up to the height of 15 meter, or you can say to fall by the distance of 5 meter, it will take time of 1 second. And we know the time of fall and time of ascent is same for the same distance, right? So total time duration, so we can write total time duration for which the ball was above the 15 meter, that will be 1 plus 1, that is the 2 second. This is the first method, you can say. Or another method is, see, we can calculate how much time it will take to go this 15 meter, right? We can calculate it. S is equal to ut plus half at square. S is equal to 15 meter. Again, u is 20. So 20t plus half acceleration is minus of 10 and t square. So this will be 15 is equal to 20t minus 5 t square. So this is a quadratic equation. We have to solve it. So I'm writing it in standard way. So this will be minus 5t square plus 20t minus of 15 is equal to 0, or we can write 5t square minus 20t plus 3, sorry, plus 15 is equal to 0. We can take 5 as common, so t square minus 4t plus 3 is equal to 0. We can write, we can factorize it. So this is t square minus 3t minus of t plus 3 is equal to 0. We can write it t minus 3 minus t minus 3 is equal to 0, or you can say t minus 3 and t minus 1 is equal to 0. So we are getting two values, t is equal to 3 or t is equal to 1. Let us explain the meaning of these two answers. when we ask from the mathematics that when the ball will be at the height of 15 meter, the mathematics tells us that it will be at two different time, that is at t is equal to 1. It means when we will throw it upward, that is the u is equal to 20. First time it will be at the height of 15 meter, at here t will be 1, right? After that it will go upward, and again it will start falling, right? And again it will come at 15 meter, right? So at this time the time will be 3 seconds. So that's why here the two times has been came. So for what time duration it was above the 15 meter? So time duration, required time duration will be 3 minus 1, that is the 2 seconds, right friends? So this was the answer of second part, and it's complete our second question also. Let us see the next question. Let us see let us see the third question. According to this, a car of mass m kg is towing a trailer of mass 300 kg down a straight hill inclined at 3 degree to the horizontal at a constant speed. Let us first picturize this situation. So this is an inclined plane, and this angle theta is 3 degree to the horizontal. There is a car of mass m kg which is towing a trailer of mass 300 kg at a constant speed. Since its speed is constant, direction is also constant, direction is also same, there is no change in direction, so we can say its velocity is constant, or we can say if the velocity is constant, its acceleration will be equal to 0. Since its acceleration is 0, its net force on the system will be equal to 0. The combined net force on the system will be 0. Let us read the next part. There are resistive force on the car and on the trailer, and the total work done against the resistive force in the distance of 50 meters. So if the distance is equal to 50 meter, so work done against resistive force is equal to 40,000 joule, right? So we can calculate this work done. Let us suppose the total resistive force is F, right? Fr, that is the resistive force, into displacement, that is the 50 meter, that should be equal to 40,000 joule. So we can find here the total resistive force, that is the Fr, that is the applied on the system, that is the 40,000 joule divided by 50 meter. 0 0 cancel out, so this is 800 newton. This is the total resistive force on the system, right? So the total work done against the resistive force in a distance of 50 meter is 40,000 joule. The engine of the car is doing no work, and the tow bar is light and rigid. This is the very important statement we will explore in the next part. So we have to find the value of m. So if we draw the free body diagram as a combined whole system, let us assume there is a mass of 300 plus m kg, right? There will be a vertically downward weight, that is the 300 plus mg, right? If we break the component of this mg, so along the inclination, this will be 300 plus m g sine theta. This is your theta, and this will be 300 plus m g cos theta, and there is a resistive force acting upward, acting opposite to the motion, since it's a resistive force. So this is the Fr having magnitude 800 N, right? So and since the net force is equal to 0, so if we write the net force, right, if we write the expression of net force, what we will write, we can write 300 plus m g sine theta minus 800 n should be equal to 0. Or we can remove this unit 800. So when we solve this, 300 plus m g sine theta is equal to 800. So 300 plus m is equal to 800. Let us put the value of g as 10. Sine theta is sine of 3 degree. So let us call the calculator and find the value of this. We can solve this. So this is 80 upon sine of 3. Let us call the calculator. So we have to find 80 upon sine 3, this, right? And after that we have to subtract minus 300. So let us subtract this minus 300. So this is 1228.5. So you are getting m is equal to 1228.58, or we can approximate 1228.6 if we round it to the 3 significant digits. So the value of m will be 1230. This will be the answer of first part. That is, the mass of car is 1230 kg, right? Let us discuss the next part. That is, it says the resistive force on the trailer is 200 Newton. First, see, the resistive force on the trailer is 200 Newton. This is the trailer and this is the resistive force 200 Newton, right? And since we have calculated the total resistive force is 800 Newton, so remaining 600 force will be acting on this car, that is the 600 Newton, right? So we can draw this diagram again here for your understanding quickly. That is, this is car and having mass 1230 kg, and this is the trailer, that is the having mass 300. This, its resistive force is 200 Newton and its resistive force is 600 Newton, right? So find the tension in the tow bar between the car and the trailer, and let us draw its free body diagram. So this is the tow bar. We have break it to sketch its free body diagram. So there will be a force mg vertically downward 1230 g. Its component will be like this: 1230 g cos theta, this is theta, and there will be a force 1230 g sine of theta, and there will be a tension, that is the T, like this. Similarly, if we sketch the free body diagram for trailer, this will be a tension T, this will be 300 g, and this will be 300 g cos theta, and along the inclination there will be additional force 300 g sine theta. If you have any problem in free body diagram, please make comment in comment section, I will explain. So, and we know the acceleration of all these bodies is 0, acceleration is 0, acceleration is 0. We have discussed this point in the first part. Since the net force is 0, acceleration is 0, so we can write the free body diagram. Net force is equal to mass into acceleration. Since, right, for, you can write for car, right, net force along the inclination should be 0. So we can write 1230 g sine theta should be equal to t plus 600. Similarly, for trailer, we can write t plus 300 g sine theta should be equal to 200. This is the 200 against this force, right? So we have the we have only one unknown, right? That is the t. So we can solve this expression from either side. Let us solve it from both part and check is the answer is same. So 1230, let us suppose g is 10. This is the sine of 3 degree. This minus 600 should be equal to t. Let us call the calculator and check it. So we have to find 1230 into 10 into sine 3, this minus 600. So the answer is 43.73. So t is 43.73. 43.73. If we round it to the 3 significant digits, so this will be 43.0, right? If we try to calculate from this part, let us calculate this. So t is equal to 200 minus 300, g is 10, sine theta is sine 3 degree. Let us call the calculator. So this is 200 minus, let us first calculate this, 300 into 10 into sine 3, this is equal to this. Let us subtract this 200, that is equal to same answer is coming 42.99. 42.99, that is we approximate it, that is equal to 43.0 in the 3 significant digit. So we can see the value of tension is coming same from both the expressions. So this complete our the third question. Let us see the next question. So according to fourth question, a total mass of a cyclist and her bicycle is 70 kg. The cyclist is riding with constant power of 180 watt up a straight hill incline at an angle alpha to the horizontal. Let us picturize this situation. So there is an inclined plane whose inclination is alpha to the horizontal, where it is given sine of alpha is equal to 0.05. It is also given that the power of the cyclist is 180 watt, and that is the constant. It always exert a constant power of 180 watt during the inclination to the hill. The mass of the cyclist along with the bicycle is 70 kg. So let us take this is 70 kg. At an instant when the cyclist speed is 6 meter per second. Since the cyclist is going hill straight up, right, along the hill inclined at an alpha degree, so cyclist is going along this direction. This is the direction of his movement. So if we draw the free body diagram, so this will be mg, right? This will be mg sine theta, or you can say sine alpha. Here this will be mg cos alpha, right? And there will be a normal force, that is the n, right? At an instant when the cyclist speed is 6 meter per second, so when its speed is 6 meter per second, his acceleration is minus of 0.2 meter per second square. Here we should take care the sign of acceleration, that is it is negative. Negative acceleration, it means its speed is going to decrease with time. As time increases, its speed is going to decrease because its acceleration is negative. Please take care this point. There is a constant resistance to the motion of magnitude f newton. So the cyclist is trying to go up with an acceleration of minus 0.2 meter per second square. So the resistive force will acting along this direction. Let us suppose this is the Fr, that is the resistive force. Right. So we have to find this resistive force F. How we can find this? Right. Let us see. We know the formula of power is equal to force into speed, or we can say velocity. Since power is constant, according to question, its power is constant, right? So how this can happen? So for power to be constant, acceleration is given, so velocity is not constant. As acceleration is not zero, since acceleration is not zero, so the magnitude of velocity will not constant. So force will also have to change. It's also not constant, right? The product of both the force and velocity will become constant. It may be, right? As we go up, its velocity will be down, right? Force will be something more, then the power will be constant. This will be the situation, right? So we have to find the value of this resistive force. We can find when its speed is 6 meter per second. At instant, we are talking about at instant when its speed is 6 meter per second. When its speed is 6 meter per second, from this formula, power is equal to force into velocity. We can find the force, driving force, we can say driving force, which the cyclist is applying. That will be the power upon velocity, that is equal to power is 180 watt, its speed is 6 meter per second, so we can say 30 newton. So we can say the cyclist is applying 30 newton along this direction, right? So we have to find this resistive force Fr, that is its resistive force Fr. At this instant, when the driving force is 30 newton, we know the acceleration, that is this. So we can write its free body diagram, right? Or we can say acceleration is what? Acceleration is net force upon mass. So this is the expression for your acceleration. So what will be the net force? So net force will be equal to 30 newton, or we can skip this unit. So this will be 30 minus mg sine alpha minus Fr upon its mass, and its mass is given as 70 kg. So this is 70 and its acceleration is sorry, minus 0.2, right? Its acceleration is negative. What does it indicate? It indicates that its speed is going to decrease. It indicates that downward force, along the downward force will be greater, but we have applied here, we have taken 30 minus this, we have taken driving force greater. Let us suppose this is the driving force, we have assumed driving force is greater, but its acceleration is negative. It indicates that the net force will be greater in the reverse direction of motion. So that's why we have taken here minus 0.2, or you can solve like this: acceleration is 0.2, but we should write like this: mg sine alpha plus fr, this minus of 30 upon 70. Here we have already we have already implemented the importance of minus 0.2. Since it's minus, we have applied the concept here. We have taken the downward force greater than the driving force. So both the expression will give the same answer. Let us calculate this. Let us first calculate from here. So this is 0.2 into 70. This plus 30 is equal to mg. Mg mass is 70. So 70 into 10 into sine alpha plus fr. So this will be cancel out. This is the 14 plus 30 is equal to 700 sine alpha plus fr. We know the value of alpha, and this is sine alpha is given at the 0.05. We can substitute this. So this will be 44 is equal to 700 into 0.05, this plus fr. We may call the calculator. This is the 700 multiplied by 0.05, this, that is the 35 plus fr. So what will be the fr? Fr will be 44 minus 35, that is fr is equal to 9. So our resistive force will be 9. This expression will also give the same result. Fr is equal to 9 Newton. The difference only is either you implement the importance of minus directly or indirectly. If you understood this, the importance of minus, you can correct in both the way. If you don't understood the importance of minus, you can't correct in both the way. So please take care. Let us see its next part. The next part is find the steady speed that the cyclist could maintain up the hill when he working at this power. So what was its power? Its power was 180 watt. Let's assume its steady speed is equal to x meter per second. So what we can do, since its power is constant, its speed is constant, we have assumed this. So power is equal to force into velocity. So its force will be equal to power upon velocity, or we can say 180 upon x. This will be Newton. This much force will be a constant force. This is also a constant force. Why? Because this is constant, so this should be constant, right? So now again, this is the constant force. If we again sketch the free body diagram along this inclined plane, so this will be mg, this will be mg sine alpha, this will be mg cos alpha, this will be driving force, that is a fd, and there will be a resistive force along reverse direction, that is a fr. So since its speed is constant, again its speed is constant, direction is constant, it is going upward along the same inclination plane, inclination is same, so its velocity is constant. along the inclination plane. So acceleration, now the acceleration will be 0. Please take care the difference between the first part and the second part. In the first part, acceleration was negative. Why? Because the power was constant, but velocity was not constant. Force was not constant. Here, the power is constant, velocity is also constant, right? So acceleration will be 0, right? So if we apply the net force along the inclination plane, we will get the net force 0. So we can write net force F net along the inclination will be should be 0. So we can write mg sine alpha plus fr should be equal to fd, that is the driving force. Should write it in the correct format, that is the f subscribed d, not f into d. It will make confusion. fd, that is the driving force. So m is 70, g is 10, sine alpha is 0.05, this plus fr, we know the value of fr. I think we know the value of fr, right? Yes, 9 Newton. We have calculated this in the first part, that the 9 is equal to 180 upon x. This will give us the value of x. Let us calculate this. So this is 70 into 10 into 5 upon 100. This plus 9 is equal to 180 upon x. This cancel out. This is the 35 plus 9 is equal to 180 upon x. So this is the 44 is equal to 180 upon x, or we can solve x is equal to 180 upon 44. Let us call the calculator. 180 divided by 44, it will give for decimal, it will give 4.09. So it will give 4.09 meter per second. This is the answer of second part of fourth question. Let us see the next question. See, according to the statement, 4 coplanar force, all those forces which acts in a plane are coplanar forces, act at a point. The magnitude of the forces are 10 Newton. This is the F Newton. This is the G Newton, and this is the 2F Newton. So basically we have the two variables, that is the F Newton and G Newton. Only two variables are there, F and G. 2F Newton is not a new variable. If we know the value of F, we know the force, this, right? So we have only two variables. So let us read the statement of the question. The direction of the forces are shown in the diagram. Given that the forces are in equilibrium, so if the forces are in equilibrium, so net force will be equal to 0. Find the value of F and G. I have already explained there are only two variables. So since the forces are in equilibrium, let us draw the component of all the forces. See, let us suppose our axes are this and this. This is our two axes. Let us draw the component. The component of this will be G cos 60. The concept is the angle, the cos component will be along that line. The cos component will be along that line along which the angle is given. Since 60 is along this line, so the cos component will be along this line, G cos theta, right? And this will be G, and this will be G sine 60, correct? So 2F, if we break the component of 2F, so this will be along this direction, this will be 2F cos 40. Why cos 40? Since this 40 is along with this line. So cos component will be along this line. So 2f cos 40, and the second component will be here 2f sine of 40 degrees. Let's clean this. And this is already in the alignment of the axis. So no need to break this force, right? So since the forces are in equilibrium, so net force will be equal to 0, right? So these two forces should cancel each other, right? To cancel out or to be in equilibrium, these two forces should be in equal. So 2 cos 40 degree, 2f cos 40 should be equal to g cos 60. This is the first equation, and addition of these two forces should be equal to this force. So we can write g sine 60 plus 2f sine 40 should be equal to 10. So we have two equations, two unknowns. We can solve this, right? We have two equation, two unknown. So how we can solve this? We know the value of cos 40. Let us solve this. 2f cos 40. Let's call the calculator. Cos 40. So this is approximately 0.766, 0.766 is equal to g, and cos 60 is basically 1 by 2. So we can write f is equal to g by 2 into 2 into 0.766. So f is equal to g upon, let us call the calculator, 4 into 0.666, 4 into 0.7666, right? So this will be 3.064, 3.064. If we substitute this value of f, so this will be g into root 3 by 2 plus 2. G is, f is g upon 3.064 into sine 40 should be equal to 10. So we can calculate the value of g from here, no problem. We have calculated, this is one equation, one unknown. You can solve it. So I am leaving this question at this stage. Next part is, so let us see the part B. According to this part, the value of f is 3. Find the value of g for which the resultant of forces is perpendicular to the 10 Newton force. Let us see the diagram of the question once again. See, this is our original diagram, right? This is our original diagram. So the value of f is given, that is the 3. So this force will be equal to 6, right? This is also equal to 3 Newton. So the resultant force should be perpendicular to this 10 Newton force. If we dissolve the components of these force, so along this we will get 6 cos 40 degree, and the y component will be along this part, and this will be 6 sine of 40 degree. Similarly, the component of g will be broken in two parts. This will be g cos 60 degree, and its y component will be along this, and this will be g sine 60. So the resultant of these forces should be perpendicular to 10 Newton force. The perpendicular direction of 10 Newton will be along this direction, either this way or this way. So So these two components should be cancel each other. The resultant force should be along this direction. So there should be no any component along this direction, either this way or this way. So these two forces will cancel out this 10 Newton force. So we can write, let us write it at proper place. So we can write G sine of 60 degree plus 6 sine of 40 degree is equal to 10. So we can write G sine 60 degree is equal to 10 minus 6 sine 40 degree, or G is equal to 10 minus 6 sine 40 degree divided by sine of 60 degree. After solving, we will get our answer. Let us call the calculator. So first of all, we are going to find 10 minus 6 sine 40. So this will be 10 minus 6, or we can say 10 minus 6 into sine 40 this is equal to this divided by sine 60 is equal to 7.09. So the value will be 7.09. This is the answer of part B. Let us see the next question. See, a cyclist starts from rest at a fixed point O, so, and moves in a straight line. So let us suppose this is the fixed point O. Here a cyclist right. So there is a cyclist who start from rest. So its initial speed u will be equal to 0, moves in a straight line before coming to rest k second later. So this is u is equal to 0 at t is equal to 0. After t is equal to k seconds, its speed is again 0. So its final speed is again 0, right? The acceleration of the cyclist at the time t seconds after leaving O is, so its acceleration is, that is, a is equal to 2t raised to power minus 1 by 2 minus 3 upon 5 t raised to power 1 by 2. Please see, its acceleration is not a constant, its acceleration is variable. Its acceleration is variable. It is varying with respect to time. So we can't simply apply v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. We can't apply directly because these are applicable only for constant acceleration, or you can say uniformly accelerated motion. These formulas are applicable only for uniformly accelerated motion. So the acceleration of the cyclist is this for the time duration 0t less than equal to k. So for this time duration, the acceleration is variable and it is varying like this. So this is the function of time. First question is find the value of k. What is the k? K is this. After k seconds, it stops again. So what is the value of k? Let us solve this. So we know the acceleration is basically dv upon dt. It's a dv upon dt, and here it is given 2t raised to power minus 1 by 2 minus 3 by 5 t raised to power 1 by 2. So we can integrate it. Dv is equal to 2t raised to power minus 1 by 2 minus 3 by 5 t raised to power 1 by 2 and this is the dt. We can integrate it with respect to time. So v will be equal to, integrating both sides, v will be equal to, when we integrate it, we will get 2 t raised to power 1 by 2 upon 1 by 2 minus 3 by 5 t raised to power 1 by 2, sorry, t raised to power 1 by 2 plus 1 divided by 3 by 2. What's the formula? Formula is integration of x raised to power n dx is equal to x raised to power n plus 1 divided by n plus 1 plus c. There is some integration constant, that is the c. So there will be an integration constant, that is the c. So after solving this, we will get v is equal to 4 t raised to power 1 by 2, 3 cancel out, minus 2 by 5 t raised to power 3 by 2 plus c. This is the value of speed, or we can say this is the function of speed or velocity. So to find the value of c, we can put it, we know at t is equal to 0, v should be equal to 0. So after, when we put this, 0 is equal to 0 minus 0 plus c, so we will get c is equal to 0. So our velocity function will be completely defined as 4 t raised to power 1 by 2 minus 2 by 5 t raised to power 3 by 2, right? So our question is, what is the k? We know its velocity will be 0 at t is equal to k. At t is equal to k, its velocity should be 0. So 4 k raised to power 1 by 2 minus 2 by 5 k raised to power 3 by 2 should be equal to 0. We can substitute it. Let k raised to power 1 by 2 is equal to z. So we can write it 4z minus 2 by 5, and this is the z cube is equal to 0. So we can take z as common. This will be 4 minus 2 by 5 z square is equal to 0. So we will get either z is equal to 0 or 4 minus 2 by 5 z square will be equal to 0. When we solve from here, it will be 2 by 5 z square is equal to 4. So z square is equal to, this will cancel out, 10. So z is equal to root under 10 plus minus root under 10. What's the z? Z was our root under, we have substituted it, z is equal to root under, or k raised to power half, or you can say root under k. So root under k is equal to plus minus root under 10. So when we compare this, we will take k is equal to 10. We will neglect the value of negative minus of root 10, because it's the time, and time cannot be negative. We are solving for time, and time cannot be negative. So value of k is coming as 10. From this part, we will get under root k is equal to 0. So we will get k is equal to 0. So maths tells us that for k is equal to 0 and for k is equal to 10, the speed of the particle or cyclist will be 0. And it is correct also, because its initial speed was 0. So t is equal to 0, speed is 0. So this completes our first part. Let us see the second part. Find the maximum speed of the cyclist. We have to find the maximum speed. How we can solve this? So for maximum speed, see, at maximum or minimum, we know at maximum or minimum, we know in mathematics, for any function to be maximum or minimum, dy upon dx should be equal to 0. After that, we will check d2y upon dx2, right? If it is greater than 0, if it is less than 0, or if it is equal to 0, right? So what's the rule? Rule is, if d2y upon dx2 is greater than 0, that's the point of minimum. If d2y upon dx2 is less than 0, that's the point of maximum. And if d2y upon dx2 is equal to 0, need further investigation. Okay, so we have to find maximum speed. So we have to find dv upon dt, right? We have to find first dv upon dt, then we have to equate it to 0. Then we should check the sign of dv d2v upon dt2. It should be negative for maximum. So dv upon dt, that is called acceleration, and it is already given. Our acceleration function is given as 2 t raised to power minus 1 by 2 minus 3 by 5 t raised to power 1 by 2. This is dv upon dt. It is given in question. So we have to solve it for 0. Okay, let us solve this for 0. So when we will solve this, 2 t raised to power minus 1 by 2 minus 3 by 5 t raised to power 1 by 2 is equal to 0. Again, let t raised to power 1 by 2 is equal to z. We can let it z. So what's the function will be, what's the equation will be? It will be 2 upon z minus 3 by 5 z is equal to 0. So this will be 2yz is equal to 3 by 5 z. So when we cross multiply it, so this will be 10 by 3 is equal to z square. So what will be z? So z will be equal to square root of 10 by 3 plus minus, right? But we will take only plus because we are solving for time. So we will take z is equal to under root 10 by 3. And what is the z? Z is basically root under t is equal to root under 10 by 3. So t is equal to 10 by 3. It means at t is equal to 10 by 3, dv upon dt is 0, and at it means its velocity or its speed will be either maximum or minimum, right? But here we can check it by d2v upon dt2, right? It will be negative. We have to find the maximum speed. So to find the maximum speed, we should put the value of this time in the expression of speed. We have the expression for speed, right? We have derived it for first part. This is velocity is basically this 4 t raised to power half. So 4 t raised to power 1 by 2 minus 2 by 5 t raised to power 3 by 2. Let us check it. Yes. So we have to substitute the value of t. So v will be equal to 4 into 10 by 3 raised to power 1 by 2 minus 2 by 5 10 by 3 raised to power 3 by 2. When we will solve it from the calculator, you will get the required answer. I have done this in calculator, and we are getting it as 4.87. So this will be 4.87 meter per second. So this is the maximum speed at t is equal to 10 by 3, right? The last part is find an expression for the displacement from O in terms of T. Now we have to find the displacement. Hence, find the total distance traveled by the cyclist from the time at which she reached her maximum speed until she comes to rest. So we have to find the total displacement. We can solve this. See, so we know the expression for velocity, that is the 4t raised to power 1 by 2 minus 2 by 5 t raised to power 3 by 2. And we know v is equal to dx upon dt is equal to 4t raised to power 1 by 2 minus 2 by 5 t raised to power 3 by 2. Again, we can integrate it. Dx is equal to 4t raised to power 1 by 2 minus 2 by 5 t raised to power 3 by 2 with the dt integrating both side at t is equal to 0. Its displacement was 0. At t is equal to t, let us suppose its displacement is x. When we will integrate it, we will get x is equal to 8 by 3 t raised to power 3 by 2 minus 4 by 25 t raised to power 5 by 2. This is our expression for displacement. We have to find the displacement when it reaches the maximum to the time when it stops. So we can integrate from here. Integration of dx is equal to integration 4t raised to power 1 by 2 minus 2 by 5 t raised to power 3 by 2. This dt, when t is equal to 10 by 3, x was 0. We have to calculate from here. So we can assume it x is equal to 0. 2t is equal to 10, because at t is equal to 10, it stops. And let us suppose displacement is x. So we have to integrate and put the value of time. So integration will be 8 upon 3 t raised to power 3 by 2 minus 4 upon 25 t raised to power 5 by 2 with the limit 10 by 3 to 10. After putting this value, you will get 20.747 from the calculator. This completes our last part. Let us see the next question. Let us see question number 7. A bead A of mass 0.1 kg is threaded on a long, straight, rigid wire which is inclined at an angle of sine inverse 7 upon 25 to the horizontal. Let us picturize this situation. So there is a rigid wire which is inclined to the horizontal at an angle of theta, and we have given theta is equal to sine inverse 7 upon 25 with respect to horizontal. A is released. So let's suppose this is the bead A. A is released. Since it is released, so we can assume its initial speed is 0. From rest, it is also written, and moves down the wire. So it is moving downward direction. This. The coefficient of friction between A and the wire is mu. So coefficient of friction is mu. When A has traveled 0.45 meter down the wire, let us suppose A has traveled from this to this position, and this distance is 0.45 meter down the wire. Its speed is at this instant, this was at t is equal to 0. After going down distance of 0.45 meter, its speed is, it is written 0.6 meter per second, right? So we have to prove the coefficient of friction, that is the mu, is 0.2. 0.25. We have to prove this. So let's start the solution. First of all, we should make its free body diagram, or we have to show all the forces. So this will be mg, its component will be mg sine theta, this will be mg cos theta, and there will be a normal, that is the n, right? And there will be a friction force since it is given mu, so there will be a friction, that is resistive force in the opposite direction of motion. So this will be F. So we can find acceleration here. What will be the value of acceleration? Acceleration will be net force upon mass. What is the net force along the movement? That is the, since it is going downward, so mg sine theta will be greater, so we can write mg sine theta minus F upon m. What will be F? F is mu n, so this is mg sine theta minus mu n upon m. What is the n? N is basically, n will be equal to mg cos theta, since there is no movement along the perpendicular direction of the wire, no movement along the perpendicular direction of the wire. So n is equal to mg cos theta. So we can substitute this. So this is mg cos theta minus mu mg sorry, this will be mg sine theta minus mu mg cos theta upon m. So we will cancel out m. So acceleration will be g sine theta minus mu cos theta. This will be the expression for acceleration, and this will be true for any bid A or B or C, anything, because we have proved it generalized case, right? Whatever will be theta, whatever will be the mass, it is independent of mass. So it will depend only on theta and the mu. It is dependent only on theta and mu, right? So we can find the acceleration of any bid from this expression. So we know the value of acceleration, right? Now we can apply the fundamental equations of motion. We can apply v square minus u square is equal to 2as. So we can apply v. What is the v? 0.6 whole square minus u is 0 square is equal to 2. A is basically g sine theta minus mu cos theta into s. What is the s? S is 0.45 meter. When we will solve this with the help of calculator, we can get the value of mu 0.36 is equal to 2 into 10 into sine theta is basically 7 by 25 minus mu cos theta will be 24 by 25 into 0.45. If there is any problem regarding the value of cos theta, please make comment, please write comment in comment section. You can find it with the help of a triangle law, right? So from here, if you calculate the value of mu, you will get mu is equal to 0.25. No problem, straightforward calculation, right? So we get the value of mu. Let us see its next part. Next part is saying another bead B of mass 0.5 kg is also threaded on the wire. So let us again picturize this situation. So this was bead A who fell down till here, that is the 0.45 meter. Now according to question, there Another bead B having mass 0.5 kg is also threaded on the wire at the point where A has traveled 0.45 meter down the wire. It hits B instantaneously at rest on the wire. So initially its speed was 0, right? A is brought to the instantaneous rest in the collision. The coefficient of friction for B is 0.275. So we have to find the time from when the collision occurs, right? Let us suppose at this time collision occurs, T is equal to 0. When the collision occurs until A collides with B again. So we should think of when and why A collide with B again. So if we think carefully, when it collides, it will block A will get instantaneously in rest, and bid B, which was instantaneously at rest, becomes in motion, right? So bid A will also start its motion again. It will start from the rest, and it will again increase its speed, and it may collide with the B again. So we should apply here the principle of conservation of momentum first to find the initial speed of B. What was the initial speed of B? So we can write just before the collision, just before the collision, and just after the collision. Just before the collision, speed of A was 0.6 meter per second. It is given in the first part. Here its speed was 0.6 meter per second. Initial velocity just before the collision was 0 meter per second. Just after the collision, right, VA is 0. It becomes instantaneously at rest. VB we don't know just after the collision. So we can apply the principle of conservation of momentum, principle of conservation of momentum. We can apply it M1 V1, or you can say M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. We can write it 0.1 into 0.6, 0.5 into 0 is equal to 0.1 into 0 plus 0.5 into x. We have assumed this x, right? So when we solve this, we can get x is equal to 3 upon 25, or you can say x is equal to 0.12. So speed just after the collision for bead B is 0.12 meter per second. So let after t seconds of collision, both will collide again. So after t second of collision, both will collide again. It means the distance travel in t seconds by both the bits should be same. We can calculate it very easily for bead A after the collision. U is 0, time is equal to t. What was its acceleration? So acceleration is g, we have derived it in the first part, g sine theta minus mu cos theta. When we will substitute this, we will get 10, 7 by 25 minus, now we get the value of mu, that is the 0.25 into cos theta will be 24 upon 25. After substituting, we will get 0.4 meter per second square. So we get the value of u, we have to find time, we have the acceleration. So what will be its distance traveled? S is equal to ut plus half at square. Initial velocity, initial speed is 0, so this is 0 plus half acceleration is 0.4 into t square. This is the distance traveled by the bid A. For bid B, what we can write? See, its initial speed u is equal to 0.12 meter per second. Time is equal to t. Acceleration, we can find it, that is the g. Same expression we can use, but here the value of mu is different, so we have to put accordingly. So 7 upon 25 minus 0.275 into 24 upon 25. So after solving this, we will get 0.16 meter per second square. So what will be the distance traveled? So S is equal to ut plus half at square. So you will get 0.12 t plus half. Acceleration is 0.16 into t square. So both these distance travel should be equal, then it will collide again. So according to question, we can equate this. 0.4 t square should be equal to 0.12 t plus 1 by 2, 0.16 t square. From here, we can solve this. This will be 0.2 t square is equal to 0.12 t plus this will be 0.08 t square. So 0.2 t square minus 0.08 t square minus 0.12 t is equal to 0. Let us solve this. So this will be 0.20, 0.08. So 0.12 t square minus 0.12 t is equal to 0. We can take it common. 0.12 t, take it common, so this will t minus 1 is equal to 0. So what this will be, so either t is equal to 0 or we will get t is equal to 1. So it will collide after t is equal to 1. So so time taken to collide again will be t is equal to 1 after the collision. So this completes our question number 7 and this paper also. So friends, if you like this video, please like and subscribe our channel and share this video to all of your friends to get maximum benefit. Thanks for watching.